Okay, we are solving question 2, October 2023, paper 4-2. Alright, so the question is we have an integer that is said to be divisible by another integer if the result of the division is also an integer. For example, 10 is divisible by 1, 2, 5, and 10. Okay. 10 is not divisible by 4 because it does not return an integer number. Then they are all divisors of 10. Okay. So iterative calculate totals all the divisors of its integer parameter and returns this total. So if the parameter is 10, the total will be 1, 2, 5, and 10. So we are basically dividing the value, let's say 10, by all values before it. 10 by all values before it till 1. So this is kind of like factorial, but in factorial we multiply. Here we are essentially dividing. Okay, a pseudocode is given. We're skipping this. They're saying write the program code for iterative calculate. Okay, so we just have to convert this into a Python code. Okay, this should be very simple. So function iterative calculate like this, and we're passing in a number as a parameter, and then to find will be set to number, and total is set to 0, and then while number is not equal to 0, if we're checking if to find modulus number is equal to 0, then total plus equal to number, and we're doing end if, then we go outside one indentation level and we do number is equal to number plus equal to minus equal to 1, and then literally we're just returning the value of total outside the while loop. Okay, this is literally it. Okay, write the program code to call iterative calculate with 10 as a parameter and output the return value. Okay, so we'll have the main program here.
Can you explain what?
So if we run it, we get 18. Okay, so how do we get 18 again? We are dividing 10 by all the values from 10 till 1. So 10 divided by 2 is equal to 5. And then 10 divided by 3 is not a divisor, and 4 is not a divisor, 5 is a divisor too. Then 10 divided by 6, 7, 8, 9, and 10. So these are the values that we get. So it's also divisible by 1. And then it's also divisible by itself. So when we add all of these numbers together, all of the answers here of the division, so we get 1 plus 5 plus 2 plus 10, which would be 18. So this is what the question is giving. So we simply divide this value by all the values till 1, and whatever the answer of the division is, we are going to add all the numbers, and this is only for where the modulus is not equal is equal to 0. Okay, where the values are actually divisible, so they're divisors. Okay, so we have to run this, and output is 18. We'll take a screenshot and add it into the evidence file. Then in the part B, they're saying iterative calculate has been rewritten as a recursive function. Okay, so let's try this.
Why did
Yep, so this is given. We have right program code. Okay, so the function is incomplete. We have function recursive value, we have number, and we have to find. Okay, and then it says if number is equal to blank, then we are going to return 0, else we are going to modify to find. So we'll check if to find, then number is equal to 0, then return something dot and plus recursive value number minus 1, and this will be to find. Okay, I will just finish the fill in the blanks in a bit. Else we are again have recursive value number minus 1 comma some dots. Okay, I believe this is the whole thing. Okay, so we understood what we're doing in the iterative part. So what we're doing is we are decrementing the value of number every time. So when we start number from 10, it becomes 9, then 8, then 7, then 6, then 5, 4, 3, 2. Eventually it goes all the way till 1. Every time we're checking that the number is divisible, let's say the to find value is divisible by the number. So the number is 10 here. right? Or the to find is 10 here. So we are changing the value. Is 10 divided by 10? Yes. Is 10 divisible by 9? No. 8? No. 7, 6, 5. So yes, it's divisible by 5. Since that is the case, we are going to add this value, which is 5, into our total. Previously, we added 10 into the total, then we add 2 into the total, 1 into the total. And we are decrementing number every time. So now we have to convert this into a recursive call. Okay, so what is going to be the base case here? When are we stopping the function? When we are eventually reaching the number equal to 0, and that is when the loop stops. So the same condition would be written here. When number reaches 0, we return 0, and then the recursive case, the base case is reached, and recursive calls stop. Okay, otherwise it says if toFind is blank, number is equal to 0. Okay, so what is equal to 0, and then we are going to make a recursive call where we're subtracting the number by 1 and toFind remains the same. So number is subtracted by 1, toFind remains the same as here, and where it is equal to 0, so yes, it's going to be modulus. So we'll just replace it with the modulus sign. Perfect. And then they're saying recursive call. So when we do the recursive call, we are constantly adding the number into the total here. And we do not have the total here because we'll be adding it on the go in recursion. So whatever answer this returns will get added into the current value of the number. So let's say the value of the number was currently 10. So whatever this recursive call function returns, we start from 10 and then we're changing the number to 9, then 8, then 7, then 6. So what we'll do essentially here is, okay, let's finish this, then we can just discuss it. So here, since it's before the recursive call, this will always be returned. Any blank before the recursive call will be a return. And then here we'll have minus. Okay, so here we have the return and then number minus 1. Okay, so the second parameter is toFind. And as in the question above, toFind is never changed, right? So we'll just write toFind as it is, and toFind will not change because toFind is basically our source value. Let's say we pass in 10, so 10 would be the toFind that will not going to change, and the number will change every time. So 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, now this is the main part of this code that we have to understand. So number plus recursive call this. So what will happen is when we talk about the recursive calls, I'll just draw them here. So recursive calls will be, so initially, let's say if the number is, we're setting the number here to some value, it will be the same initially. So number would be 10 plus recursive value would be 10 minus 1, 9, and toFind would remain the same, 10. Okay, so now from this recursive call, we call the function again, and next time we say return, the number would have been minus 1 now. So now we make a recursive call for this line, and it would be 9 plus recursive value of 9 minus 1 is 8 comma 10. Then it would be 8 plus recursive value of 7 comma 10. So this will keep on happening until we reach the base case. In fact, let's do it for 4 maybe, because 10 would take a lot of time. In fact,
what do you mean by the
this is the recursive call, right? This is the recursive value function, so it's constantly calling itself. So every time it's going to add the value of the number, and then it's going to make another recursive call to itself. So that is what I'm tracing here. So currently the value was 10, and then we set it to 10 minus 1, 9, and then this was the first recursive call. Then the next time value is 9 of the number, so we add it into the recursive value, which the number value becomes now minus 1 becomes 8. Then the next time number is 8, and then the number minus 1 becomes 7, and this will keep on repeating. So 7, 8, so we'll have, just a second, so I'll just copy it. 8, then this will be 7, and then the number becomes the number minus 1, 6, then 5, so on all the way till the end when it would be 1, and this would become 0. So when this becomes 0, number becomes 0 here. Now the solution says that we're going to return 0. So when we return 0, this literally changes to 1 plus 0. So this solution becomes 1, and then we'll go back to the previous recursive call and we'll return 1 there, and then we'll keep on passing on the values of the, so we should add 5 here as well, because 5 would return a value, return value 5 4 comma 10. Okay, so we had this one here, so this one is returned like this. Then we know that in case of 5 we would have returned a value as well. So when we divide 5 by 10, we know that it is going to return a value, and the number was 5. So this whole thing again would return a 5. And then from the previous value we had 1 from the previous recursive call, so this becomes 5 plus 1 6. Then this recursive call will end because it didn't return us any value. Same for this, same for this, same for this. And then we go all the way back up, and then we know that 10 would have gotten us a value of division, whatever the division we did, which would be, so in case of 10 it would be 10. So then this would be 10 plus 5 plus 1, and I missed the value of 2 as well. So 2 would have also returned a value, and then 1. And then if we add up all these stack traces, so 1 plus 2 plus 5 plus 10, so it gives us 18. So this is how we actually do it, and this is literally making the stack calls, stack traces of a recursive call. So whatever the recursive call is, we just write it as it is, and we keep the variables same, or we change them wherever it says. So the number was, let's say 10, so 10 minus 1 becomes 9. 2 find remains the same, and we keep on doing it until number becomes equal to 0. When the number returns 0, we start evaluating the previously pending recursive calls onto the top of the stack. So this should be working. They might ask us to, so they're saying yes. Now you have to test it. So print recursive value for 50 and 50. Okay, let's see if this works or not. Okay, it gives us 93. So we should double check by passing in 50 here in the first one as well. Yep, 93. So that means both of them are matching. So both of them are working correctly as intended. They are saying test the program and take a screenshot of this. And with this, the question is done. Question number 2.